Alright, so this question is from static electricity, and it says two identical tiny spheres of mass 2 grams and charge q are suspended from point by tiny thread 10 centimeters long. They are equally charged and repel they repel each other to a distance r. At equilibrium, the string makes an angle of 5 degrees with the vertical. Find the magnitude of the charge on each sphere. So we know that the best way of us drawing this simple illustration, it has to be like this. And the other one is somewhere like this. We're going to have this charge and the other one here. So the distance between these two charges is supposed to be r, this and that, like this. So this is where the strings are connected to. They make an angle of 5 degrees each with the vertical. So this question applies now. It requires us to use the system of resolving every force for every charge. So I can resolve the force on this charge, it will be the same thing even to that given charge. By the way, if I want to write, or rather to resolve this tension which is here, and it is 10 meters, or sorry, 10 centimeters long, meaning that it has to be like this. I'm going to resolve this, which is attached to this one, it has to be resolved like this. The other one is going to be like this, the other one is going to be like this, and the other one pointing towards the distance. So remember, if I'm to divide this into two different distances, you find that this is going to be x, that one also is going to be x whenever you cut it here, meaning that r is going to be equal to what? X plus x. Okay, so before we even come to finding the value of x, remember we have the angle, which is 5 degrees. What are we supposed to do for that angle? We can use Sokatoa specifically sine 5 degrees is going to be equal to, so this can be drawn like this is going to be opposite. Once you turn the angle, you draw it like this, and then you make like this, and this is going to be the vertical distance here, and this is going to be my x. The angle 5 degrees is going to be here, 10 centimeters is going to be somewhere there. So sine goes with the opposite, which is x over the horizontal 10 centimeters. Then x is going to be equal to 10 sine 5 degrees. So x is going to be equal to what? You try to punch in your calculator. You try to punch this on your calculator. Okay, so 10 sine 5 degrees, we are getting 0.87. I can write this one as 0.87. This is the value of x from here up to somewhere there. Now for me to find the entire value of r, what I would say r has to be equal to x plus x, whereby r is going to be equal to 0.87 plus 0.87. Okay, now remember this is in centimeters, so r is going to be equal to, whenever you add these two, you're going to get 1.74 centimeters. So we can convert this to what? To meters before we move any further. R is going to be equal to 1.74 centimeters divided by what? Divided by 100 centimeters, repeated within inside the brackets in a form of meters. And then our r is going to be equal to, let's say, 1.74 divided by, okay, so this becomes the value of r, 0.0174 meters. That is the distance from here up to there, the separation between two different charges, or rather the spheres. Now I have to come back to this so that I know the forces that acts on this thing. So it will be like this. I know that the mass is going to point in a form of weight. Here to have the weight. Then here, since it is repelling each other, this is what my force of electric force in short. Then we have the angle at the vertical part here. If we follow this one, since the angle is being formulated somewhere here as 5 degrees, this is making an alternative angle. Even here we're going to have 5 degrees, and this is going to be what? Since we are trying to resolve the tension, this is going to be T cos 5. Remember, the axis that is cut by the angle carries cos. Then this one is going to be what? T sin 5 degrees. Okay, then you have to say the summation of forces in X must be equal to 0 since it is at equilibrium. Even the summation of forces in Y must be equal to 0. That actually means that the upward forces has to be equal to the downward forces. So T cos 5, this has to be equal to what? It has to be equal to mg. Then these forces again, they must balance. So say T, that is in x-axis, T sin 5 has to be equal to this force, electric force, has to be given by the formula Q1, Q2, then over R square. This R which is here is the distance we are finding. Okay. And then you can make T the subject of formula from here. You're going to have T equal to mg over cos 5 degrees. But the mass, by the way, it has to be converted to what? It has to be converted to kgs. We have the mass is given as 2 kgs. Sorry, it has to be given as 2 grams. So whenever you convert this to kgs, you have to multiply this by 1 kg over 1000 grams, which is going to be equal to 0.002 kgs. That is the mass. Forward. We can take this and replace where there is, sorry, this is tension. I will take this and replace there to have mg over cos 5 degrees sin 5 degrees equal to, remember here the charges are the same, they're identical, meaning that you can just put like this, you say q square over r square. So this and this, they're going to give us what we call tan. We're going to have mg tan 5 degrees equal to k q square over r square. You multiply this and that, we're going to have r square mg tan 5 degrees equal to k q square over k, even here over k. Whenever we make q the subject of formula, we find that it has to be the root of r square mg tan 5 degrees over k. That q is going to be equal to, so whenever I try to punch this on a calculator, it will automatically give you 7.6 multiplied by 10 to the power negative 9, which is just one and the same, like 7.6 nanocoulomb. That becomes the final answer. Thank you. Subscribe to my channel, follow our Facebook page.